I am Darshan from Department of Computer Science and Engineering, Sri Venkateswara College. Today in the subject of operating system, we will be discussing about the topic process scheduling. In this presentation, we will be exploring the fundamentals of process scheduling, which is a vital aspect of operating systems. At first, we need to know what is a process scheduling. Process scheduling in the operating systems method to manage execution of processes by allocating CPU time, ensuring efficient multitasking, resource utilization, and fair processing prioritization. Now, introduction to CPU scheduling. At first, balancing the load. CPU scheduling efficiently allocates the CPU to different processes, ensuring fairness and optimal system performance. It's like managing a busy restaurant, ensuring each customer gets served timely. Then the role of the scheduler is the scheduler is responsible for selecting the next process to run based on predefined algorithms, deciding which task gets their turn on the CPU. Now, scheduling algorithms. Some of the scheduling algorithms are FCFS, which is also known as first come first served. Processes are served in the order they arrive, simple and straightforward. Think of a queue at the bank, customers are served in the order they are arrived. Then next comes the shortest job next. Processes within the shortest burst times are prioritized, minimizing average waiting time, like a doctor prioritizing patients with urgent conditions. Priority scheduling. Processes are assigned priorities and higher priority processes are given preferences in the CPU allocation. Next comes primitive and non-preemptive scheduling. Preemptive scheduling, which means in preemptive scheduling, a higher priority process can interrupt and take over the CPU from the currently running process. It ensures better responsiveness and it's ideal for real-time systems but may cause overhead due to the frequent context switching. Example includes round robin and priority scheduling. Then non-preemptive scheduling. In non-preemptive scheduling, a running process cannot be interrupted until it finishes or voluntarily releases the CPU. It is simpler and avoids context switching and overhead but may lead to longer waiting time for other processes. And its examples are FCFS and priority scheduling. Next, scheduling queues, which are ready queue and IO queue. The ready queue contains processes that are prepared to execute and are waiting for the CPU allocation. These processes have all required resources except the CPU. IO queue. The IO queue holds the processes waiting for the input-output operations to complete. These processes cannot proceed until the request IO operation is finished. Then long-term schedulers, medium and short-term. At first, long-term schedulers manages processes admission by selecting which jobs to load into the memory, controls degree of multiprogramming and balances CPU-bound and IO-bound processes for system efficiency. In medium-term scheduler, it handles processes swapping by temporarily suspending or resuming processes. It frees memory for active processes, optimizing resource usage and reducing the CPU consumption during heavy loads. Short-term schedulers select which processes from the ready queue to get to the CPU access next, operates frequently ensuring the quick decision making for efficient CPU utilization and smooth process execution. Context switching and its importance. Fast transition. Context switching is the process of switching between running processes, saving the state of current process and loading the state of next process. Efficient use of CPU. It is important for maximizing CPU utilization and ensuring smooth multitasking. Multicore scheduling and process affinity. Multicore scheduling, which means optimizes CPU usage by distributing the processes across multiple core. It ensures load balancing, reduces the contention, and enhances performance through parallel execution and efficient resource utilization. Process affinity, binding a process to a specific core for improved performance and consistency. Now, let us discuss the conclusion points. Efficient scheduling ensures optimal CPU utilization, balanced resource management, and smooth process execution. Technique like preemptive, non-preemptive, and multi-core scheduling enhances system performance, meeting diverse computational needs in modern computing environment. Finally, process scheduling is an critical element in the efficient operation of any operating system. Understanding the various scheduling algorithms and their implications is crucial for maximizing system performances and responsiveness.